to talk about balanced forces and unbalanced forces, what the difference between them is, and how to find net force. Okay, so before we start, we're going to define balanced forces. So a balanced force is when I have equal and opposite forces that result in no motion. And that's my key here. When I have a balanced force, that's what I need to know about it. When it's balanced, there is no motion present. Okay? So, if balanced is no motion, unbalanced is obviously going to have motion. So, I would define it as two or more forces that result in motion. Okay, so again, my key word here is motion. I will have motion if it is unbalanced. All right, so let's look at some examples of balanced and unbalanced forces. Okay, so my first example is cards balanced. When they are tipping on each other, I have equal and opposite forces, so there is no movement, so I would consider that to be balanced. Okay? Pushing a box with opposite and equal force. That is the definition of a balanced force. So if I have the same amount of force pushing this way that I do this way, it's going to be balanced. It will have no motion. Okay? An example of an unbalanced force is one person pushing a rolling chair. So let's say I take my chair and I push it across the room. I'm applying a force to it, but there's also a force working against my chair, which is friction. My force is greater, but friction eventually will slow my chair down enough that it will stop. But it does have motion, so it's considered to be unbalanced. Okay? A man in a parachute is another example. When I have a parachute, I've got two forces at play. I've got air resistance that's pushing up, and gravity is pulling down. Gravity is the greater of the forces, so I do drop. However, because air resistance is at play, it's going to be a slower fall. Okay? An arm wrestling stalemate. Stalemate means that no one is winning. There is no movement. So that would be an example of balanced. Okay? Another example of unbalanced is pushing a skateboard. Again, I have my force where I push the skateboard. Then friction is the opposite force that's at play. And so my force is greater, so the skateboard moves, but friction eventually will slow it down enough that it does stop. Okay, one more example of balanced would be me standing, just standing, okay? The floor pushes up on the person, gravity is pulling down, they are equal and opposite, so you are able to stand on the floor without floating or sinking, okay? Now let's talk about how to calculate net force. So in this first example right here, I see two forces. I've got 5 newtons pushing on the box to the right, and I've got 7 newtons pushing on the box to the left. So when they're opposite forces, what I do is I subtract. So I have 7 newtons minus 5 newtons equals 2 newtons. I can't stop here though. I have to say what direction the force is going to move in, or the object is going to move in. And so because 7 is my greater force, the direction that that force is headed is the direction my object will move. So my answer is 2 newtons to the left. Okay, let's try another one. Here on example 2, I've got 5 newtons coming to the right, and I've also got 7 newtons pulling to the right. So on this example, they're working together, so I want to add them. So I've got 5 plus 7 equals 12 newtons. And since they're both working in the same direction, my answer is to the right. Okay, let's do one more example. Okay, I've got 5 newtons going to the left. I've got 7 newtons headed to the right. Because these are opposite, we're going to subtract again. So 7 minus 5 is 2. And then this is my greater force. It is headed to the right. So my answer is 2 newtons to the right. Now, it is very important that we include our unit of measurement, okay, and that we tell what direction it is going in. Without these two things, if I were to just write 2, I would consider that wrong. We have to have all 3 components for it to be a net force, okay? Let's look at one more type of problem. Here on this type of problem, I have a ball, and it tells me that I have 10 newtons of force pushing to the west, and I have 10 newtons of force pushing north. So how do I solve that? Do I have equal forces at play? Well, I've got 10 and 10. So yes, my forces are equal. But are they opposite? So what is the opposite of up? Well, the opposite of up is down. So do I have a downward arrow here? No. So these are not opposites. Because it's not equal and opposite, I do have movement. Okay? So what is my net force? Because I know I have movement, I'm going to add these together. So I have 20 newtons. And then I would use my cardinal directions. It's going to go diagonally this way. So if I use my compass, that would be to the northwest. Okay? So is this an example of balanced? Well, I have motion here. It's not equal and opposite, so no, I do not have a balanced force. The reason is it is not opposite, so there is movement. Okay, if you have any questions about this, please come see us.